All right, today we're going to talk about ocean currents. And ocean currents, let me just get the PowerPoint up here. Ocean currents are mass movements or flow of ocean water, similar to a river within the ocean. And currents are constantly moving and influence the climate, living conditions, and life found in an area. There are two types of currents. There are large-scale currents, which are surface currents, and then density or thermohaline currents. And then there are also small-scale currents or local currents, such as tidal currents and longshore currents. So the first one we're going to talk about are the big picture currents, the surface currents of the Earth. So these currents move water horizontally and parallel to the Earth's surface. They're found only in the upper 330 meters of the ocean, and they're influenced by factors such as solar heating, wind, gravity, and the Coriolis effect. The Coriolis effect we'll talk more about during weather, but they move in a pattern of rising air. So if we look here at the planet, and here is the way the winds are blowing. So here we end up having at the equator moist air rising. As it rises, it sinks. It gets cooler and sinks, and then as it flows back towards the warming area, it flows into this pattern. So that's called the trade winds. And then we also have cold air up at the poles. So that's dry air that's sinking down. Well, as it sinks, it goes down towards 60 degrees north latitude. As it travels that way, you get the polar easterlies. We live under the westerlies. So these areas that span between 30 and 60 degrees latitude, where wind is kind of in the middle. So you end up having warm, moist air rising up toward at the poles at 60 degrees north latitude and then sinking down towards 30 degrees. And as it goes up back towards, gets pulled up by the polar vortex, it goes from the westerly direction towards the east. Now, currents move at a 90-degree right angle, left or right of the wind current, depending on the hemisphere. So these air masses drive wind currents or drive ocean currents. And it's important to the transport of life. So the primary factors, primary factors that move water are solar heating, wind, gravity, and the Coriolis effect. So the solar heating is due to solar radiation. When water heats, it starts to expand because it has more kinetic energy. The molecules move faster, therefore it spreads further apart. Near the equator, the surface is slightly higher, creating a slope. Because the water at the equator is moving faster and they're spread out a little bit further, they actually have a slope. And the water will tend to flow downslope as it goes from the equator out towards either pole. Now the wind that we talked about, the global wind currents, push the surface water. So here we have the westerlies are traveling in this direction, and as they're traveling, they're pushing the surface water. And the water piles up in the direction of movement. Global wind belts help to create the current pattern. The force of the wind is then balanced by the Coriolis effect. The Coriolis effect is when gravity pulls water down the slope or the pile and is caused by wind or thermal expansion. The Coriolis effect is created by the rotation of Earth as it moves towards the east. This causes water to move or turn around the mound of water, causing a spiral. In the northern hemisphere, water moves to the right, to the direction of wind. So it moves in this direction here. And then in the southern hemisphere, it moves to the left, to the direction of wind. These are known as gyres, or large mounds of water that flow around them. And it's produced in all of the major ocean basins of the world. So there are 5 major ocean gyres. When we look at these ocean gyres individually, we're talking about a boundary current. It's when a balance is met between the Coriolis effect and the flow, and it's called a geostratigraphic current. Boundary currents are the major currents that are formed around a gyre. The Gulf Stream here is an example of a western boundary current. So the current comes up from the equator, hits the continent, and starts to go out towards Newfoundland. And then if you look at here, this is Florida up towards Maryland, and then it flows outward, and it's going to go out towards the Atlantic, towards London in England. So these warm currents can be either warm or cold depending on where they originate. So currents on the west coast of continents and on the east coast of ocean basins bring up cold water. Currents on the east coast of continents or the west coast of ocean basins bring up warm water, and these help to regulate climate throughout the world. Now, there are two other factors known as upwelling and downwelling. Upwelling is a circulation that's caused by wind blowing parallel to the coast. It happens when wind is blowing north to south in the northern hemisphere or south to north in the southern hemisphere. As this wind pushes upward, pushes against the coastline, it's moving the water. Well, as it moves the water, water from below has to come up from below and take its place. So think about being in a pool. You're in the pool and your brother or sister is there with you, and you take the water and you just start pushing it at them. Well, you don't make a hole where the water was. Water from below fills in that space. So upwelling works the same way. As an upwelling, that water comes from below, it actually brings up high concentrations of nutrients, which promotes plankton growth, which are plants, which are the basis of the food chain in the ocean. This attracts large quantities of fish, and you have very big areas of fisheries where there's areas of upwelling. Downwelling is the opposite. It occurs when the winds are blowing parallel to the coast, so it happens when the wind is blowing south to north in the northern hemisphere, or north to south in the southern hemisphere. And it pushes water downward along the coast and prevents nutrients from coming to the surface. So wherever there's downwelling, fish populations will decline in that area. Now we have these two smaller local types of currents, known as tidal currents and longshore currents. So tidal currents are a result of the rise and fall of water level due to tides, which is a vertical motion. But it creates a horizontal motion as water moves towards or away from the shore and causes the movement to go in and out of bays. And there are two types of flows. You have the ebb flow, where it's coming from the shore and returning to sea, and you have the flood flow, where water is coming from the sea toward the shore. You know these just as tides. So a tide is a tidal current. It's the movement of water in and out of the bay. Longshore currents run parallel to the coast. And a longshore current is generated when a train of waves reaches the coastline and release a burst of energy. And it's affected by the velocity and angle of the wave. Anytime you've been at the beach and you've seen the kind of a train of waves coming into shore, that's a longshore current. These currents move up onto the beach, capturing sediment and causing beach erosion. So when we talk about these ocean currents, we talked about surface currents and local currents, but there's also one more. There's deep ocean current circulation. In the ocean, water circulates due to density differences. And the differences are typically due to temperature and salinity. And these create a vertical current in the deep sea, bringing nutrients to the top. This is known as a density or thermal haline current. It forms when salt water becomes more dense, causing it to sink, slowly spreading across the bottom of the ocean. These are very slow-moving currents, and they move as little as a few meters per month. So where do you think density currents will form? And I will tell you that in class tomorrow. So how are currents measured? In the early years, we used to use a drifter or an observer, and a timer was used to figure out how currents were measured. Today, buoys are used to measure the current. And we don't need to really know the different types, but just know that as the water passes, it measures the currents. All right, I will see you guys tomorrow. Remember to complete your WISC, and don't forget to make sure you put in a question of something you still don't understand or need help with. And I'll see you tomorrow.